Well, thank you for having me. My name's Sylvia Martinez, and I've just done 2 workshops and 2 sessions here at FETC about the maker movement, how to get started with making, project-based learning, and a session on girls in STEM.
Oh, awesome.
Ooh, nice.
You know, we've had a few discussions here about girls in STEM, and that's a real big one. I have 2 daughters, and I get it completely. And, you know, that's the interesting thing. I have to tell a quick story. My first career was a band director. That's what I started off as. And the 3rd year, I had a massive bass drum line in my marching band that was all 6 girls. And they were phenomenal. Took them all over the country. And every time we show up at a percussion festival, all the guys would come and go, "Oh my gosh, those girls are phenomenal." I was like, yeah, because girls, they get it. They really do at a very early age. And it's interesting, girls get it before most guys do. And yet we've left them out of science and technology for so long, or made them feel like, hey, wait, you don't need to do this. This is your job. And we've missed out in a whole generations on an opportunity to get ourselves moved forward as a country. And it is what it is. But yeah, I find that girl power is great. It has to be in my house. I have 3 of them. I have to.
You're outnumbered.
I'm outnumbered. But it's a wonderful outnumbering, I can tell you that. So makerspace,
Yes.
one of our favorite things. So here, give us a little synopsis of your session.
Well, it's become a thing. We wrote a book about 3 years ago called Invent to Learn, Making Tinkering and Engineering in the Classroom. And right after we wrote it, we went to ISTE and did a session on Maker, and it was like the only one. And then next year there were like 5 sessions, and I wrote a blog post, and the next year there were like 30 sessions. I thought, okay, I give up. This is the thing now. Everyone's doing it. You know, it's a combination of things. Mm-hmm. It's the outside world. The maker movement in the real world is a global revolution of instant, just-in-time industrial technology that's coming down in price so rapidly that it's changing the way people live, the way people work, the way people do business all over the world.
Right.
Combine that with the internet and people feeling like there's a global community out there to solve problems, to share solutions, make them better. So you have the means, you have the access, you have the information, and all of this is happening, and schools can be part of this.
Yeah.
This exciting, these people are learning, and schools should be paying attention to all of this. The tools are perfect for having kids work in areas of science and math that on paper and pencil, they're just not alive.
Yeah.
You know, it's this hands-on learning, and kids can make real things.
Yes.
I think that's what you hit on that's really great. We work with a company out of Arkansas that are 2 science teachers who were doing a lot of 3D printing, and then they realized how hard it was for some schools to grasp it. And the cost. Now, they got the cost amazingly down, which you're right. Now, you can buy 6 3D printers for the price you can buy 1
only
for.
begun.
Yeah, and it's only begun. It's going to get better and better. But these guys have really got it out there, and they're showing them how to. You want to use it in social studies? Let us show you how to do demographic maps. Let's print this. But it's not just that. It's that problem-solving skill that we're teaching kids and how to apply to every part of the curriculum, every part of it. And you're exactly right. That's the part that I like that you said, is that there are these everybody's doing it, and if we need to know how to fix a problem, we can just reach out on the net and find it.
That's right.
Yep.
You know, and the way that every job, you know, we talk about preparing kids for these good STEM jobs and everything. Well, not just STEM jobs, but every job now uses the computer, and people have to communicate and reach out and work together and make things and do things together. And we should be, you know, kids are who they are at a very early age. You know, we don't have to teach kids about being a paleontologist. They can do very similar work to a paleontologist. They can take scans of bones. They can join the sort of detective story about what kind of dinosaur this is, or what kind of, you know, the animal you found in the ground. And kids can do that today. Yeah. And I think that's anytime we can have a kid be a historian, be a mathematician, be a scientist, instead of them teaching them about stuff.
Yeah.
I think it brings them into the learning process. And that's what we want. We want kids to have agency. We want them to own their own learning.
Yeah.
You can't do learning to a kid.
No, you
Right.
can't.
Yes.
Right?
Exactly.
You know?
Yes. You can't do
We're going to
learning.
steal that one. Hold on a second.
That's right. You can't do learning.
We had
That's right.
Christopher Freeman here earlier from Virginia Beach City, Virginia, and he's an environmental science teacher, and his kids got to help design their new school. And they're one of the only schools in the country that have bees on premise, and the kids are weighing them and studying them and sharing the information with them. And you're exactly right. We don't have to tell these kids how to do. They already know how to do. We just have to give them the opportunity to take that. And we're seeing it now pop up and flourish.
And
all
that's
around
the
country.
fantastic opportunity of places like FETC is teachers can come together and share what they're working on. They can share great ideas. They can learn from each other. And find out that teachers are good designers too. There are teachers who've designed tremendous programs that give kids these opportunities to do real things and learn real things. You don't have to be handed a book and do the lessons out of the book. You don't have to wait for someone else to tell you what to do. Everybody can be a part of this.
Yeah.
And teachers are doing absolutely fantastic things with kids.
We know it's people like you that come in and help those teachers. And it's like FETC. There's enough sessions, there's enough hands-on that a teacher will find that place they need the spark. They need that one thing. Where do I start? That's always the hardest part. Starting anything is the hardest part.
Absolutely.
But here is that place that they can usually find it, because there's enough sessions going on, enough hands-on that they can find poster sessions. But the poster sessions are awesome. This is my first time. So when I saw that, I told David, he had told me about it, and I walked up and I was like, wow, this is crazy.
Yeah. You can try to explain to someone
Yeah.
what happens at FETC, but until you're here, you just don't get it. So, it's very hard to
I think a lot of
visualize.
people have a mistaken impression of the maker movement of it's just you put a lot of these magical tools on the table
Right.
and step back, and the kids are instant geniuses, and
Right.
they stumble across the Pythagorean theorem, and it's like people have this very weird vision of teaching. It's either kids sitting in rows being lectured at, or they're wandering barefoot in a field, and they're just stumbling across. It's like, wait a second, there's all this in between. And teachers have tremendous gifts and can think about how you set the table, how you prepare the learning environment, what you choose. You can't you go down to the exhibit floor, you couldn't, you don't have the money, you don't have the time, you don't have the space to put all that stuff, and you wouldn't want to.
Right.
You want to pick the best. You want to pick the things that really support your vision of learning in the classroom.
Right.
And you know what? You don't always need the most expensive stuff. You don't always need the fanciest tools.
Right.
And sometimes it's better not to have too much stuff.
Right.
You want kids to get good at something.
Yep.
Yes, exactly. Yes.
Yep.
Yes.
And for the facilitator, it makes it a lot easier when you start off that way. And and there's the thing I like to use a lot. You're not necessarily a teacher anymore. You're a facilitator. Yeah. Same thing, but now, especially in the makerspace movement, and I think the hard part we're from Arkansas, so a hard part we see there is that a lot of parents think that, and a lot of people think, well, they're just in there making toys. They're in there. No, that's not it. So the whole part of the makerspace movement is that it came on so fast. I don't think we clearly defined it just yet. It's getting definition now, and it's starting, especially what we see from vendors and services provided. They're helping us define that, and they're getting a better idea of what we need. We'll buy the product later, and they realize that, but let's hope you get started with the plan. What do you need? What do you need to do? And they're helping us hone in on that one thing, like cardboard. What a great piece. So many kids are building cardboard. A lot of maker spaces use cardboard to build the cars and buildings and the Eiffel Tower. You talk about cheap and easy.
Absolutely.
Yeah.
I think you never want to throw away good materials, good ideas, good projects. You build on them.
Yeah.
Right.
Cardboard is great. Well, why can't you add LEDs? Why can't you add a microcontroller? Make a cardboard robot. So that these become part of a child's toolkit
Right.
that they can use to make meaning in the world. And that's the most important part of this making. It's about making meaning and letting the kids make sense of what's inside of them, what they wonder about the world, and it's every subject area. It's math and science and all the things we want kids to learn should come together. In our book we talk about 3 categories of materials in a maker space that we think are real game changers, and it's physical computing, fabrication, 3D printing, and programming. And it's not because those are all fancy and newfangled. It's because when combined with traditional crafts, with traditional projects, you can really create that iterative design opportunity using software and hardware where you can make real things. And I think the opportunities are so extraordinary today with what's being designed, with what's coming down the pike. And, just as a teacher, being able to say, you know what? I don't have all the answers, but we'll figure it out together.
That's right.
What a great model that is.
It is a great model. That's a great model. And I have to say that your enthusiasm is contagious. So
That's fantastic. My first job was as an aerospace engineer.
Really?
Wow.
Absolutely.
That's
I worked
awesome.
on the GPS satellite navigation system, something that was completely a theory when I was in college. And when we got there and they said to us, okay, now this is going to work. We put up the satellites, make it happen. And we all went, oh, we don't know how to do it. But you
Right.
know what? We figured it out together.
Right.
And I think that a challenge is the most fascinating thing in the world.
I
What's
agree.
better than having a problem to solve?
Yeah,
What's
that's-
more fun? How boring would it be if everything was just done for us?
Yeah.
Right, exactly. Well, and that's what, and I think that is a perfect lead in to the other main focus that you had mentioned earlier was girls in STEM. Jeff talked about it some, but I'd like to get your input, your perspective, some of the things that you talk about in your presentation about girls and women in those STEM areas.
So I think first of all, I always start with that if we made science and STEM areas more gender fair, it would benefit all students, not just girls, not just students who are traditionally understood, everybody. I love the idea that there's a great STEM job out there where everybody's going to make a lot of money. But you know what? I really want kids to feel like they are competent. Like they can look at scientific information and make a decision. Like they're not scared of math.
Right.
I want citizens, and I don't care if they're artists or historians or musicians or mathematicians, they should be able to be part of the solution finding that we need in this world.
Yeah.
Girls are particularly interested in science because they see it as a way to make the world a better place.
Yeah.
And there are scientific careers that have now tipped to be more women than men.
Yeah.
But they tend to be in biology and environmental science and social sciences and psychology. Computers and engineering are not the place where you find a lot of women.
Right.
Now, a lot of schools of engineering are trying to change that. They're trying to change the way that courses are taught. They're trying to make sure that there are women instructors, that the students get a sense that there's a community of women, that they aren't alone.
Yeah.
And I think K-12 schools can take a lot of lessons from that. Making the spaces inviting, making it, extending the invitation to everyone, even if you're not that STEM kid.
Right.
Because look, I was great. I was good at school. Well, I was great at doing what I was told.
Right.
Right.
You know?
Yeah.
And I'll tell you, my
Yeah.
second career was video game designer. And there were a lot of programmers there who had even dropped out of high school
Yeah.
because they weren't allowed to do what they cared most about, which was program computers.
Yep.
You know why they weren't allowed to take computer science? Because they were bad at math. I'm making air quotes, right?
Right.
Right.
They were so-called bad
Yes.
at math.
Yes.
Typically what they were bad at was doing what the teacher told them to do.
Exactly.
And they got shunted out and told that you don't belong, you don't have a science mind, you don't have a math mind. And then they went and became some of the most brilliant people I've ever worked with.
Yeah.
Well, I would tell you, my son started. My son's 21. He's, in fact, he'll graduate in December. Crossed fingers and all. But he started out computer science, and what absolutely turned him off, and he actually wanted to go into game design and gaming, and what ultimately turned him off was the math side. And it's not even necessarily that he's quote unquote bad at math. He was. Well, it really goes down to what you said. He was bad at doing what the teacher told him to do. I mean, that's ultimately what it was. He understood a lot of the concepts and got a lot of the ideas, but he ran into two major problems. One, he couldn't quite figure out the way that particular professor in any particular class wanted a particular answer told. Never mind that he solved the problem. It wasn't done in this particular way. And so that was killing him. And then
6 plus
learning
3 and
all
4
of
plus
those, 5. and then going through a lot of the advanced math steps and frankly hoops that you have to jump through. A lot of those folks don't make the connections as to why am I learning all this math when I'm trying to make a game. I don't understand how they're linked. That doesn't make any sense. And it totally it totally disenfranchised him from the whole premise of doing it at all. And which is very unfortunate because I think he would have been brilliant at it. And who knows, he may later in life decide, we'll do this. But it goes back to kind of what you were saying, he didn't like it because he couldn't do what he was told.
There's a lot of kids in K-12 education working really hard at things that don't matter much.
Yeah.
At math that they'll never use, at memorizing words, and it's a shame because imagine what they could do if they were working hard at things that matter.
Yes.
So it's up to educators to find those things that matter, connect them to curriculum, and sometimes prune the curriculum.
Yeah.
We teach a lot of math that was invented because there was no computer.
Yeah.
Math to explore the universe, math to look at small things, math, all of these things, and we still teach it.
Yeah.
When nobody uses that.
Right.
When I was an engineer, the math that we used was the math that we needed immediately. And some of it had just been invented.
Yeah.
If they'd said to me when we were doing navigation software, well, we're going to use, to solve this equation, nobody would go and factor things out by hand. You had computers for that.
Right.
Yeah.
And you had to use the computers because they're the only ones fast enough to make the decisions when you're in a jet and it's, it's got, nobody's waiting for a guy drawing an equation on a chalkboard.
Yes.
The jet's halfway around the world, right?
Yes.
Look, you need baseline things, but a lot of stuff you can learn in real time. And when you need to know it, there's a lot of things that you can learn, in real time.
Yes. Well, and the advantage to learning that way is not only is it that kind of just-in-time learning premise, but it's not just in time. It's also this is when I need it. And guess what? Now it's exactly what I need to know at this point. It's perfectly relevant to what I'm doing. I don't know how to get to this particular point. Oh, well, here's the math, here's the whatever, the formulas, here's the application that already exists because somebody else wrote it that helps you get there. And now you're going to have to learn this part in order to get to that step. Why teach it to you back in 8th grade when you're not going to use it for another 6 years?
And this is not a surprise.
No.
How many times we have this horrible curriculum, it's an inch deep and a mile wide, and we waste kids' time, and it's boring, and blah, blah, blah. So let's have a new math curriculum. Oh, now look what we've done.
Right.
We looked at the list and said, we forgot this, and now let's add this, and now let's add that. And all of a sudden, you've got an inch deep and a mile wide, and everyone complains, and we all look around and go, I thought we said that. What happened?
Right.
Where is the revolution? When are we going to actually change things?
Yeah. Unfortunately, I think sometimes the revolution is not the go get them, change things revolution. It's the revolution of coming back around again where we just were. It's the other kind of revolution. I'm like, you're using that word wrong. That's not the revolution we're
It's like
wanting.
a wheel just going around. It's like, I've been here before.
That's not
I've been here
revolution
before.
we were looking for.
Yes.
And the easy path is always that of least resistance is always the one that gets taken. And I think that's where we are.
And look, I talk to teachers all the time, and I feel their pain. It's a real dilemma. I think I sort of visualize them as they got each foot on a polar ice cube, and they're floating away, and the ice is melting, and they know what's good for kids,
right?
And yet the test is tomorrow, and they can't not help the kids do well in the system that exists today.
Right.
So I think it's a difficult thing to hold those two ideas in your head at the same time.
Yeah.
That we can help kids today and work to change the system.
Yeah, exactly.
I agree.
Yeah.
I agree.
Man, awesome.
Anything else you want to share with us?
I think that I've had a great time at FETC. I think this is absolutely fantastic. You guys are doing this. How many interviews have you done?
We've
A
done
lot.
every 15 minutes.
Pretty much.
Amazing.
Pretty much, yeah.
Yeah, and we
Amazing.
started this a year and a half ago. We were having lunch at a Dairy Queen.
Yeah.
I'm a musician and I was a band director, and I worked some radio, and David had worked some radio in college. We said, we should do a podcast. We like to do this. We like to talk. I got into tech in the 90s. No, my minor was computer science with Cobalt and everything else a long time ago.
No, I remember.
And so the old Vax Lab.
Yeah.
We're all sitting down there pasty-faced working the Vax Lab.
Yeah.
But, and we both decided, we like to talk, but we never meet a stranger. We both have a really fun time getting to know people and like to follow the rabbit down the rabbit hole when we learn something. And we do a weekly show every Wednesday at 4. And we started doing conference coverage because we wanted to hear people's stories, their ed tech journey, their story about education, their story about what they do. And we find that once they get in the seat and we start talking, it helps them too, especially folks that have never done that before. They sit down and start telling you what they do, and then they realize maybe, I am pretty good at what I do. This is really important to someone. It's important to us. And now it's going to be important to other people. We're going to put it out there. And if 5 people listen to it, 5 people listen to it. And if 5 million people listen to it, 5 million people listen to it. Yeah. So it's
Really terrific.
it's fun. We have
fun.
and we have a blast. So
Well, that's good.
we're kind of some nutty guys, so it's fun.
Yeah, that's fun. But
Well, thank you for having
Can I
me.
get your picture?
thank you very much for coming and
Sure.
sitting with us. And he's gonna get a picture while
Okay.
he's doing that. You can just say right there,
Oh,
we're,
okay.
we're on the air, we're on the radio. So
Right.
Just, hey, you just
I
take
was
a
just going to walk away.
That's right.
That's a bad radio. Yeah.
No, that's all good. And so we'd like to give you a little
Thank you.
something for putting up with us and having to sit in the hot seat.
Awesome.
And so take that with you. And
Thank you so much.
And I tell you what,
thank you.
I will
anytime,
wear it proudly.
new book coming out anytime?
Well, since we wrote Invent to Learn, we decided to start a publishing company.
Oh, wow.
We have 9 books now, most of them written by educators telling their stories, just what you said.
wow.
Thinking through what they do and then sharing it with the world.
Right.
So that's at cmkpress.com.
Okay.
CMK, the letters, press.com.
Okay.
We'll tweet that out.
Invent to Learn is there, and all of our books. We have a guide for making in the K-3 classroom. We have a brand new book called Making Science, written by a middle school teacher who teaches science, regular middle school science, in a makerspace.
Awesome.
How she did it, how she started, her thought process.
awesome.
So we're really trying to give teachers voice because